Okay, today we study the another chapter, complex number. This is the new chapter. So there are two number system. So one is real number system, another is complex number system. So we have altogether two number system. So today we are going to study this complex number system. So what does actually this mean? So what type of number includes in this system? Let's study about it. As you know that, so let's take one example. X square plus 4 is equal to 0. यदि हामीलाई यस्तो इक्वेसन सल्भ गर्नु छ भने यहाँबाट x को भ्यालु कति आउँछ सल्भ गर्दा हाम्रो हुन्छ x स्क्वायर इज इक्वल टु -4. दिस इज द सल्भिङ है. सल्भिङ गर्दा +4 बिकम्स -4. अब x भनेको यहाँ रियल नम्बर हो. यो इक्वेसन सेटिस्फाई हुनको लागि x को ठाउँमा हामी जुनसुकै नम्बर पनि राख्न सक्छौं. जुनसुकै नम्बर राखेर लेट्स चेक. यदि x को ठाउँमा 1 राख्दाखेरि 1 स्क्वायर और 2 स्क्वायर यो -4 हुनको लागि त 2 स्क्वायर इज इक्वल टु 4 हुन्छ. बट हियर इज -4. -2 को स्क्वायर गर्दा पनि के हुन्छ +4 नै हुन्छ. बिकज वी नो दैट स्क्वायर अफ एनी रियल नम्बर is not negative. So one statement is over here. Square of, that means square of any real number never be negative. Never be negative. That means if you put +2 or -2 over here, then it will not be equal to -4. यहाँ x को ठाउँमा +2 अथवा -2 राख्दा यसको स्क्वायर गर्दा नेगेटिभ कहिले पनि आउँदैन. That means we can't find the solution of x from this expression, from this equation. So if you write down the value of x is equal to like this, x is equal to -4, then we can't find this solution because -4 square root of -4 is not any real number. So it does not give any real number extracting from this number. यो नम्बरबाट नेगेटिभ नम्बरको स्क्वायर रुटबाट हामी स्क्वायर रुट हटाउन सक्दैनौं. त्यसैले यस्तो खालको नम्बर चाहिँ सल्भ गर्न नमिल्ने भएको हुनाले द कम्प्लेक्स नम्बर इज डेभलप्ड. यसमा रियल नम्बर x को भ्यालु कुनै पनि रियल नम्बर आउँदैन. त्यसैले यो नम्बर सिस्टम यसमा चाहिँ रिजेक्टेड भयो. रियल नम्बर सिस्टम रिजेक्ट भएपछि अर्को न्यू सिस्टम अफ नम्बर इज डेभलप्ड. दैट न्यू सिस्टम अफ नम्बर इज कम्प्लेक्स नम्बर. That's why so new complex number is system. So we can write down the definition. It is definition. So let's talk about definition. Any number in the form of a plus iv, where a and b are real numbers and I is equal to root under -1 is imaginary unit. Imaginary unit is called a complex number. Complex number. This is the definition of complex number. So it is denoted by, complex number is denoted by Z and W. So one of the most important things is a plus iv. So here we can see a and b are the real number. A र b को ठाउँमा कुनै पनि रियल नम्बर आउन सक्छ. सपोज 2 + 3i, 2 - i, 2 + 4i. a र b भनेको एउटा रियल नम्बर सिस्टमको र्यासनल इरेसनल नम्बर जुनसुकै यहाँ राख्न पाउँछौं हामी. र यसमा त्यही भएर रियल नम्बर सिस्टम, रियल नम्बर. And I means the one of the another symbol, new symbol is presented over here. So that is I. The value of I is root under -1. I को value root under -1 हो, जसलाई इमेजिनरी युनिट भनिन्छ। त्यो सिस्टम अफ नम्बरलाई हामी कम्प्लेक्स नम्बर भन्छौँ र यस्तो खालको फर्मलाई हामी जेड अथवा डब्लु लेख्न सक्छौँ नोटेसनमा। लेट्स सी one example. So z is equal to 2 plus 3i. This is the complex number. Here a means 2 and b means 3. 2 and 3 are real number and the I means imaginary unit. And z is equal to -5 minus 4i. This is also the expression of complex number. Here value of a is -5 and value of b is -4 and this is imaginary unit. So similarly z is equal to a plus iv. So here real part of z is equal to, this is called real part of z. So in this case we have this is the real part, this is real part where I does not belongs. यसमा I छैन, यो I नभएको पार्ट रियल पार्ट हो। रियल पार्ट अफ z is equal to a and imaginary part of z is equal to, that is b, and this number b is called imaginary part because it is along with I सँग भएको पार्टलाई हामी इमेजिनरी पार्ट भन्छौँ। यो इमेजिनरी पार्ट, यो रियल पार्ट। That's why it is real part of z means REZ and it is imaginary part of z means IMZ is equal to b. So in this way we can write down the number in complex form. This is the complex form, complex number form. So any number which can be expressed in this form, that is called complex number. So in this way we can find out so one of the terms over here, I is equal to -1. So let's talk about the I or imaginary unit. Imaginary unit. So first of all we can talk about the definition. So some definitions over here also, some definitions. So number 1, so let z is equal to a plus iv or a comma b. Write down a comma b and w is equal to c comma d. A comma b means also can be written as a plus iv and c comma d means also can be expressed in c plus id. So in this case, so if we add both complex number together, then a comma b plus c comma d, then it can be written as like this. So how to add or how to sum these two complex number? So let's take real number. This is real number, this is imaginary number, imaginary part. This is real part, this is imaginary part. This is real part, this is imaginary part. So we can add real part and real part altogether, a plus c. Similarly imaginary part and imaginary part, this b plus d. So this is the sum of any two complex number. So we can define the sum of any two complex number like this. So for this we can add first number and first number. That means actually real part plus real part. Similarly imaginary part plus imaginary part. So in this way we can add any two complex number. And the number 2, z into w. So z into w, that means a comma b into c comma d. So when two complex numbers are multiplied together, then how to multiply? According to the definition, this is also definition. So let's see, a times c, here is ac minus b times d, bd. So first number into first number, ac, minus second number into second number. Similarly first and last, ad plus second and second, that is bc. Multiplication को definition में हामीले चाहिँ AC पहिला लेख्छौँ, A into C minus B into D, कमा फेरि A into D हामी त्यसपछि AD लेख्छौँ, A times D प्लस B times C गर्छौँ। यो वेबाट हामी मल्टिप्लाई गर्न सक्छौँ कुनै पनि कम्प्लेक्स नम्बरको, दुईटा एनी टू कम्प्लेक्स नम्बरको लागि। सो फर एनी टू कम्प्लेक्स नम्बर we can multiply like this and it will be in the form of this one. So to understand this multiplication also we can take one example. Let's see one example. Suppose if we multiply 2 comma 3 into 4 comma 5, then how to multiply? According to this definition, how can we multiply over here? So for this, so we can suppose it, this is A, this is B, this is C, this is D. So यो 2 लाई A suppose गरौँ, 3 लाई B suppose गरौँ, 4 लाई C suppose गरौँ, 5 लाई D suppose गरौँ। त्यसो गर्दा हाम्रो रुल अनुसार A times C, that means 2 into 4 minus, so here is minus A into C multiply गर्नु पर्यो, so 2 into 4 minus B into D, that means B को ठाउँमा 3 into 5, यो हाम्रो यो expressionsमा यो भ्यालु आयो। Similarly A times D means A into D means 2 into 5 plus B into C means it is 3 into 4. So if we solve it, then we get another term. So it will be 8 minus 15, that is minus 7, 10 plus 12, that is 22. So minus 7, 22 is the product of these two complex numbers. So in this way, we can multiply by using this rule, Z into W. So we can operate like this for multiplication. Okay, let's talk about the imaginary unit. So what is imaginary unit? We deal these topics over here. So now the complex number 0, 1. Actually this term in this complex number, 0 is the real part and 1 is imaginary part. It can be written as like this, 0 plus 1 into I. And so it is only I, 0, 1, where real part is 0. We can also write where real part is 0 and imaginary part is 1. It's called imaginary unit. So in this case 0, 1 means it can be also written as like this, I into 1. 0 means real part we can ignore it, there is no number, and in imaginary part we have only one. So in imaginary part we can insert I over here. So this is the symbol for imaginary unit. It is the symbol, iota symbol, from Greek letter. So I into 1. So this is the value of x-axis and this is the value of y-axis. So along y-axis we have only one number. So along y-axis we have 1. So 0 plus I into 1 means this system. So this system I is called imaginary unit. So from this we have one rule or one property. So this is I square is equal to minus 1. So this is the property. This property can be used to solve the question in the exercises. So how to prove this one? How to prove? So this is the proof. Let's see. We are going to prove this result. So I square means I into I, 2 times of I. That means if I means what? 0, 1 into 0, 1. So this is the multiplication of any two complex number. Here I means 0, 1 and another I means same complex number 0 and 1. So if we multiply this one according to our definition, then we get this is A, this is B, this is C, this is D. We can suppose it as like this. हामी यसलाई यसरी सपोज गर्न सक्छौं. अब यसपछि A times C multiply हुन्छ 0 into 0 according to our multiplication rule. Similarly, it is minus over here, and B times D means 1 into 1, comma. Okay, we are multiplying these two complex number. So for this, we can assume as A, B, C and D. This is A, this is B, this is C, this is D. So according to the definition, we have to multiply this and this. That means A into C. This is A into C minus B into D. That is 1 into 1. And similarly, we can multiply A to D, A and D. So here A को ठाउँमा 0 छ into D को ठाउँमा 1 plus B into C, that is 1 into 0, 1 into 0. So this step is obtained from using the formula. Formula apply गरेर आएको step भयो. So 0, this is 0, minus 1. So altogether minus 1. This is 0, this is 0 also. So minus 1 comma 0. So in short, we can write down minus 1. Shortcut मा हामी यसलाई minus 1 राख्न सक्छौं. 0 imaginary part यसमा छैन. So we can ignore it. Imaginary part 0 छ. Along y axis मा भएको भ्यालु छैन भन्न खोजेको हो. X axis मा भएको भ्यालु just minus 1 छ. So we can write down I square is equal to minus 1. So this is the property, and we have to remember this property to solve the question, related question. So we are dealing some questions related to I square is equal to minus 1. So let's solve some important question which are related to I square is equal to minus 1. So we can go through the example now. Okay, we are going to solve these two questions. Just now we have studied the one of the property. So that property is I square is equal to minus 1. So let's solve this question. So solution is this one. 3I square plus I cube plus 9I power 4 minus I power 7. So for this, so here is 3 times I square, that is same. And for I cube, we can write down I square into I. And for this, we have to write down 9 into I square power 2. 2 to the 4. So in this way, we can arrange the term over here, and I square. So 2 3 is 6. And here is 1 I left. So altogether we can write down 2 3 is 6, 6 and 1 means that is 7. So in this way we can convert all the terms in I square form, because we know that I square is minus 1. That's why यहाँ भएको टर्महरुलाई I square कै फर्ममा एक्सप्रेस गर्नुपर्छ, किनभने हामीसँग प्रपर्टी पनि I square कै छ. र I square र 3 को multiplication बाट 6 अनि power 1 means it is 7. So that's why. So this is the expression obtained from this one. So let's put the value or use the rule, that is I square means it is minus 1. So this is the property. And this I square means also minus 1 into I. And this is 9. And I square means again minus 1 and power 2. And this I square means again minus 1 power 3 into I. So when you calculate this value, then it will be 3 into minus 1, minus 3, minus 1 into I, minus I plus minus 1 to the power 2, or minus 1 square means it is positive. 1 and 1 into 9 means it is 9. Minus 1 whole cube means it will be minus. And minus minus means it is plus. So final answer is I obtained from this question. So I and I can be cancelled. So finally 9 minus 3 means it will be 6. So this will be the answer. So in this question, we can use the property, one of the property, I square is equal to minus 1. So remember that I square is equal to minus 1, this property. So we can write down the note, I square is equal to minus 1. So this is the property or formula or rule, which rule can be used to solve this type of question. So similarly, let's see, we can see another question over here. So this question also can be solved by using this property. So let's write here 1 upon I, here 1 upon I square. We can directly use the formula over here because this is I square. So 1 upon I cube. So first of all, break down it, I square into I, and here is also I square into I square. 2 plus 2 means 4. So we can break down or we can separate like this. हामीले I power 4 लाई I square के फर्मुला लाउने गरी I square को मल्टिपल मा ब्रेक गर्न सक्छौं. यो तरिकाबाट ब्रेक गर्ने. त्यसपछि हामी I square को ठाउँमा we can put the value. So let's substitute the value. Here is only I. We can't apply this rule because here is only I, not square. यहाँ square छैन. So leave it. यतिकै छोडौं. 1 upon I square. I square means it is minus 1. So write down minus 1 plus 1 upon I square. That is minus 1 into I. And here is also I square means minus 1. I square means minus 1. So this is the property. Just now we have used this property. So let's solve this one. What will happen? Minus minus, it will be plus. Minus into minus or minus divide minus. That will be plus. And here is 1. And here is plus and minus. It will be minus. And in numerator 1, denominator I. Minus minus plus. Plus and minus. This will be minus 1 and minus 1. So this 1 and this 1 we can cancel. And 1 upon I and 1 upon I. This is plus, this is minus. Also this is cancelled. So it will be 0. So this is the answer after solving all the terms. Let's see, we have another 2 questions. So how to simplify this one? So write down this one, 9 into minus 1 plus this is 25 into minus 1 minus 36, that is same. And here is minus 1. So write down minus 1. So how to simplify? That means same thing. 9 into minus 1 means minus 9. यसलाई यस्तो लेख्न सकिन्छ. एउटै कुरा हो. अब यसको ठाउँमा minus 1 means we can insert I square. This is the property. I square means minus 1 or minus 1 means I square. Similarly, 25 into minus 1 means again I square. That is same thing. And 36 times minus 1 means it is I square. So now we can easily solve it. So 9 root means it is 3 and I square means it is only I. Plus 25. The square root of 25 is 5 and square root of I square means I. And square root of 36 means 6 and square root of I square means it is I. So these all are the like terms. So we can solve it. 3 plus 5, 8. 8 minus 6 means it is 2. So 2i is the answer. Correct answer is 2i. So we can solve this problem. Now we can solve this problem like this. 1 plus I times 1 plus 1 upon I. So power 4. दुवै एक्सप्रेसन को पावर सेम भएको हुनाले हामीले एकैचोटी 4 लेखेका छौं यहाँ. So write down like this. Now we can multiply this and this all together. First term into first term. that is 1 plus first term into second term. 1 into 1 by I means 1 upon I plus second term into second term. This is I plus second term into second term. That means I into 1 upon I. So this is the power 4. So यहाँको दुईटा टर्मले पाले पालो यहाँको दुईटा टर्मले मल्टिप्लाई गर्ने. So in this case we can write 1 plus 1 upon I plus I plus this I and this I cancel, and here is 1 power 4. Now we can add 1 and 1. 1 plus 1 means 2 plus 1 upon I plus I. So and this is the power 4. Now we can take LCM of I, and if you take the LCM I, then it will be I into 2. 2I plus, that is 1 same, and I into I square. So LCM लिएपछि यस्तो आउँछ, यो I LCM I into 2. 2I into I square, 1 is 1. So 2I plus 1 minus 1. I square means minus 1. I square को ठाउँमा minus 1 लेख्न पाइन्छ. This is the same rule, same property. So by using property we get like this. We can write this one, and 1 cancel, and here is I. So power 4, and finally 2I upon I. We have 2I upon I and power 4. So I and I again cancelled, and 2 power 4 means it is 16. So in this way we can solve this problem. So दुईटा 4 को ठाउँमा एउटै पावर 4 लेख्ने, दुईटा टर्मलाई एउटै ब्र्याकेटमा राखेर त्यसलाई मल्टिप्लाई गरिसकेपछि क्यान्सल हुने टर्म क्यान्सल गर्ने, त्यसपछि रिमेनिङ टर्मलाई चाहिँ एलसीएम लिएर सल्भ गर्दै जाँदा हाम्रो रिजल्ट 16 आउँछ, which is a real number. 16 is a real number. So in this way we can calculate the value. Now we have this question. So in this question we have to find x and y. This is the complex number a plus iv, and this is not a complex number now. So first of all we should multiply here. सबभन्दा पहिला यसलाई मल्टिप्लाई गर्ने, यसलाई प्योर a plus iv को फर्ममा लाने, कम्प्लेक्स नम्बरमा लाने, त्यसपछि now we can compare. So let's do this one. X minus 1 into I plus y plus 1 is same, and if you multiply 1 into 4 then it will be 4, and 1 into minus 3i means 3i, I into 4 means plus 4i. Similarly, plus into minus, it will be minus, and I into 3i means 3i square. Now we can write this number is same, y plus 1, LHS part is same, and here 4 minus, these are the like terms. Here is also I, there is also I, so like term we can add or subtract. 4i minus 3i means it is plus I, plus sign is greater, and here is plus 3 because I square is minus 1. Here the reason is I square is equal to minus 1. I square को ठाउँमा यो property use गर्ने र I square ठाउँमा minus राख्दा minus plus. So we can write x minus 1 into I plus y plus 1 is equal to 4 plus, there is I single, and 4 plus 3 means it is 7. So this is also a plus ib form, a plus ib. So for b we can write the 1 over here. So now we can comparing real and imaginary part. So x minus 1 is equal to 1. Here is coefficient of I is x minus 1. Here coefficient of I is 1. So this value is equal to this value. We can compare or equating the like terms. So if we solve it, then x is equal to 2. And y plus 1 is equal to 7. Here real part is y plus 1. And here is the real part is 7. So 7 is the real part. So write down 7. Real part सँग real part compare गर्ने, imaginary part सँग imaginary part compare गर्ने. अब imaginary part कसरी थाहा पाउने? जहाँ I हुन्छ, I भएको र I भएको कोफिसिएन्ट इक्वल गर्ने र imaginary part real part equal गर्ने. So from this we get y is equal to 7 minus 1 6. So these are the values obtained from this question. So कुनै पनि क्वेशनमा यस्तो दुईटा आई छ भने यसलाई मल्टिप्लाई गरेर एउटा सिंगल आई मा लाने भनेको यसलाई होल एज अ होल a प्लस आईबी मा कन्भर्ट गर्ने र a प्लस आईबी को फर्म र यताको a प्लस आईबी को फर्म. दिस इज अल्सो कम्प्लेक्स नम्बर, दिस इज अल्सो कम्प्लेक्स नम्बर. So two complex number are equal. So by the equality of two complex number we can write down like this: real part is equal to real part, I नभएको part equal, I भएको part equal. So in this way you can solve this problem. Now we are going to study conjugate of a complex number. So what is conjugate of a complex number? So for this we have to write down, let z is equal to a plus ib be a complex number. This is one of the complex number by our supposition. Then its conjugate is denoted by z bar. This is the symbol of z bar or z conjugate or conjugate of z. This means z bar and defined by z bar is equal to a plus ib को bar and it can be written as a minus ib. So this is the definition. यदि हामीले यो कम्प्लेक्स नम्बरमा z बार अथवा कन्जुगेट लियौं भने a plus ib मा पनि कन्जुगेट लिनु पर्यो. And conjugate means the real part र imaginary part को बीचको sign we have to change. So if we change the sign, then plus will be minus and minus will be plus. So according to our definition, we have to change the sign between real part and imaginary part. So this sign will be minus according to definition. So let's see one example. If z is equal to 2 plus 3i, then this implies z conjugate is equal to what? So if there is 2 plus 3i, then its conjugate is written as 2 minus 3i. So this is the example. If z is equal to minus 5 minus 4i, then this implies z conjugate is equal to what? Then if we take conjugate of this complex number, then it will be plus. This sign will be plus because this is the sign lying between real part and imaginary part. So minus 5 remains same and this minus goes to plus and 4i. So this is the conjugate of the given complex number. If z is equal to I only, then what will be the z conjugate? This is the question. So how to change? So I means this is the imaginary part. So real part we have 0. That's why it is 0 plus I. So if its conjugate is going to find, then it will be 0 minus I. Here should be minus. 0 minus I, or simply we can write minus I only. So in this way, we can convert the conjugate of any complex number. So let's discuss the properties of conjugate of complex number. So write down its properties. So if z is equal to a plus ib and w is equal to c plus id, then c plus id be any two complex number, then we can deduce the following properties. So real part of z is equal to 1 upon 2 times z plus z conjugate. Similarly, we have the another property, imaginary part of z is equal to 1 upon 2I z minus z conjugate. This is real part of z and this is imaginary part of z. So we can deduce this property by using this z and w or given complex number. So we have another many properties related to conjugate. So z plus w conjugate. So what will be the property? Z plus w को whole conjugate भयो भने we can separate it like this, z conjugate plus w conjugate or conjugate of w. ल सेपरेट गर्दा आउने टर्म पनि they are equal. So the same property will be for product. So if you find out the product of any two complex number, then it will be z conjugate into w conjugate. And another property is z conjugate and whole conjugate. Conjugate of z. So double conjugate means the complex number z itself. So we can write down like this. And the number 6, if you multiply z and z conjugate, then it gives always real number. So z and z conjugate is a real number. So this type of complex number gives always a real number, which includes only number, not the term containing I. So these are the properties. So one by one we can deduce this property. So we can deduce some of the properties out of them. So let's see what will be the property. Okay, we are going to prove all this property. So for this property we have to take this, let z is equal to a plus iv and w is equal to c plus id. Then here we can write the z conjugate. What does it mean? Z conjugate. So z conjugate means it will be a minus iv and w conjugate means c minus id. If we prove this number I property, then it will be z plus z bar is equal to what? Z plus z bar. Or we can take the right hand side, 1 upon 2 times z plus z bar. This is the right hand side of first property. So what will be this one? So 1 by 2 bracket z means a plus iv, substituting the value of z in this term, and plus z conjugate means this one, a minus iv. This is the term, and iv cancelled, and finally we get a times a means it is 2a, and 2 and 2 cancelled. This is a. So a means what? A means real part of z. So if you look the value of z, a plus iv is here. A plus iv ma a भनेको real part, b भनेको imaginary part. So our answer is a. That's why we can write real part of z. So real part of z is equal to 1 by 2 times z plus z bar. So this is the proof. First proof. So for third proof, we are going to show the z plus w conjugate is equal to, we have to prove this one. So to prove z plus w conjugate is equal to z conjugate plus w conjugate. So this is the another question. So for this, we can find out first of all z plus w. So for this, first of all find out z plus w. So write down the value of z from here. Z means a plus iv and w means c plus id. So if you add this term, then it will be a plus c. So a plus c is here. A and c both are real parts, and iv and id. So among them, these two terms, Now we can take common I and B plus D. It will be B plus D. So IB plus ID बाट I common लिएपछि B plus D बाँकी रहन्छ. So we can find out Z plus W को conjugate. Now we can take the conjugate of this term. Now this one. Z means Z plus W means A plus C plus I times B plus D. So its conjugate. So this is Z and this is W. Z plus W means this result. So I have written here. So this is real part, this is imaginary part. अब यो plus sign B को plus sign change हुन्छ, minus sign I into B plus D. यदि यो conjugate sign हटाउने हो भने बीचको sign plus चाहिँ minus मा जान्छ. Conjugate sign हटाउँदा त्यो अनुसार A plus C minus I times B plus D लेख्ने. अब हामीलाई थाहा छ A plus यसलाई खोल्दाखेरि A minus IB plus C minus ID हुन्छ. यस्तो हुन्छ. I into B, I into D गर्ने. त्यो अनुसार हाम्रो A minus IB एक ठाउँमा आउँछ. C minus ID is taken as one place. So A minus IB means what? A minus IB means Z. A minus IB means Z bar or Z conjugate plus C minus ID means C minus ID means W bar or conjugate of W. So conjugate of W. So in this way, this term is equal to this term or LHS is equal to RHS. Therefore, so it is proved. Hence, it is proved. So in this way, we can find out the another properties also. Absolute value of complex number. Now we are going to another sub chapter, small chapter, absolute value, or it can be said also modulus term. So let Z is equal to A plus IB be a complex number, then its absolute value or modulus value is denoted by Z bar and defined by modulus Z is equal to modulus A plus IB is equal to root under A square plus B square. Or we can say that, so this is the definition of any complex number which can be expressed in the form of this one, A plus IB. Its absolute value is denoted by these two vertical lines. This is the vertical line, this is also vertical line. So between these two vertical lines, we have to write down the complex number. Modulus of Z. We can be read as modulus Z or absolute value of Z, which is defined by like this. Modulus Z is equal to modulus A plus IB. That means by definition we can write it as A square. This A is a real part. So real part power 2, real part को whole square plus this B is the imaginary part. I सँग भएको नम्बरलाई imaginary part भनिन्छ. So it can be written as imaginary part. Imaginary part को square. So this is the formula of absolute value. Now if let's take some examples of absolute value. If we have Z is equal to 2 plus 3i, then its absolute value is given as modulus Z is equal to 2 plus 3i. How to find the modulus of 2 plus 3i? So for this, we have to take the 2 square because here 2 is a real part. So it will be real part square and 3 means imaginary part. So write down 3 square according to this definition. Here is real part square plus imaginary part square. That's why here is real part 2 and imaginary part 3. So if we solve it, then we get the some solutions. So if we If it is given the complex number minus 2 minus 3i, then how to find modulus z? So by using property, we can find out like this. This is the real part, and the real part is minus 2 whole square. And according to the formula, there should be plus in the middle. So write down plus. Then imaginary part is minus 3. So write down minus 3 square. So if we solve it, then we get some numbers. 9 plus 4, 13. Root 13 will be the answer. So in this way, we can find out the absolute value. So let's discuss its properties. Now, properties of absolute value. So for this, we take any two real number. Let z and z means okay. Let w be any two complex number. Then first property is z into w is equal to modulus z into modulus w. So this is the one of the properties. Here z and w be any two complex number. If you take modulus sign over here, then it will be modulus z into modulus w. Just separating the modulus in each complex number. And number two, if you take the any two complex number in division, then it will be modulus z divided by modulus w, where w never be 0. Denominator should not be 0, otherwise it will not be the solution. Number 3, z into z bar or z conjugate is equal to modulus z square. So this is another property. Z into z conjugate or conjugate of z becomes modulus z square or square of the modulus of that complex number. So in number 4, a real part of z is less or equal to modulus z, and similarly imaginary part of z is less or equal to modulus z. So these are the properties of absolute value. Now we can prove all the properties related to absolute value. So let's discuss this prop. Okay, we are going to prove all these properties. So for this, let z is equal to a plus iv and w is equal to c plus id. So take any two complex number. Then if we find out the modulus z, then what will happen? Then it will be root under a square plus b square. That means real part square plus imaginary part square. यहाँ आई राख्न जरुरत छैन, आई राख्न पाइँदैन. And modulus of w is equal to root under c square plus d square. This is real part and this is imaginary part. So put square in power, and if you multiply z and w, then what will happen? Then z means a plus iv into w means c plus id. This times this. So we can multiply this both terms. Then what will happen? Let's see. Then a into c means it is ac. Then a times id means adi. Then iv into c means bci. So write down bci plus. Then iv into id means I square bd. So if you solve it, Then I square means minus 1. As you know that this is the property of I square. So this means minus 1. So this sign becomes minus and BD is same. This is AC, and so from this we get minus sign because I square is minus 1. So minus BD plus, so from these two terms we can take out common AD plus BC. So in this term here is I, here is also I. So take out I common, and the remaining term AD and BC is here. So in this way Z into W means this one. So now we are going to prove this one, this term. Now modulus Z into W means what? So we are going to prove properties number 1. So if you modulus means it is modulus not necessary. Z into W means this term, and the absolute value of this term is, so by taking root of this term, so here is real part AC minus BD. So real part is AC minus BD whole square plus imaginary part is this one AD plus BC power 2. So this is done by using formula. So modulus means root under real part square plus imaginary part square. So if we solve it, then it will be A minus B whole square. That means A square C square. This is A square. This term is square minus 2. This term and this term AC BD plus B square D square. B square, that means last term is square, plus similarly we can use A plus B whole square. So first term is square means A square D square, 2 times first term into second term, that means AD BC plus second term is square, that means B square C square. So if we solve it, then we can cancel this and this here. Now we can arrange like this. We have to find the modulus Z and modulus W. So modulus Z means A square plus B square. So write down A square C square plus A square D square, this term and this term putting together, plus B square D square plus B square C square, or C square. First of all write down C square, and here is D square. So term should be arranged. यो माथि 1 2 3 4 चारवटा टर्म भएकोमा हामीले अरेन्ज गरौँ. दिस टर्म एन्ड दिस टर्म putting together, so together, and this term and this term putting together. So root under, so if you take common A square common, then C square plus D square, C square plus D square. So if you take the B square common from here, then it will be C square plus D square, this one. First यो दुईटा टर्मबाट A square कमन लिने, लास्ट दुईटा टर्मबाट B square कमन लिने, त्यसपछि हाम्रो टर्म आउँछ A square plus B square एक ठाउँमा आयो. त्यस्तै C square plus D square, we have to take only one factor. This and this एउटा term, and remaining term should be inside the small bracket. So if you write down like this, A square B square and root under C square plus D square. यो ब्रैकेट र यो ब्रैकेटलाई हामी स्क्वायर रुटलाई सेपरेटली लेख्छौं. सेपरेटली लेखेपछि अब हाम्रो this will be root under A square plus B square means what? Look at once. So root under A square plus B square means modulus Z. So for this we can write modulus Z, and for this we can write like this one, root under C square plus D square means modulus W. So in this way, this term, this LHS is equal to RHS. So we can write down this is equal to this. So hence proved.